Hi everyone. In this video we are going to solve simultaneous equations using the elimination method. We will start with what the elimination method actually means, then we will look at the key rules you need to know, and after that we will solve several examples step by step. We will see examples where the equations are already ready to add, examples where we need to multiply one or both equations first, an example with fractions, and also two special cases, infinitely many solutions and no solutions. Let's start. When we solve simultaneous equations, we are trying to find values of the variables that satisfy both equations at the same time. So the solution must work in the first equation and also in the second equation. The elimination method is called elimination because we remove one of the variables. First, we want the terms in both equations to be arranged in the same order. For example, if one equation has the x term first, then the y term, then the equal sign, and then the constant, we want the other equation to follow the same order. Next, we want one variable to have the same coefficient, but with opposite signs. At that point, we can add the two equations, and that variable will cancel out. We then solve the equation that remains. After that, we substitute the value into one of the original equations to find the other variable. And finally, we check the answer in both equations. This is important because it allows us to verify that the solution we found is correct. There are two important rules to remember. Rule number 1. We can multiply or divide an entire equation by the same number. When we do that, we get an equivalent equation. It looks different, but it represents the same relationship. Rule number 2. We can add or subtract the two equations to create a new equation. This new equation helps us solve the system. These two rules are exactly what we use in the elimination method. Let's start with the first example. We have 3x plus 2y is equal to 23, and 4x minus 2y is equal to 12. First, we check whether the terms are aligned. They are. In both equations, we have the x term first, then the y term, then the equal sign, then the constant. Next, we check whether one variable has the same coefficient with opposite signs. Here, the y terms are perfect for elimination because we have plus 2y in the first equation and minus 2y in the second equation. So we can add the two equations directly. 3x plus 4x gives 7x, plus 2y minus 2y gives 0, so the y is eliminated. 23 plus 12 gives 35, so we get 7x is equal to 35. To solve this, we divide both sides by 7, so x is equal to 5. This is our first value. To find y, we substitute x is equal to 5 into one of the original equations. We can use the first one, so we get 3 times 5 plus 2y is equal to 23. 3 times 5 is 15. So 15 plus 2y is equal to 23. Move 15 to the right-hand side. 2y is equal to 23 minus 15. So 2y is equal to 8. Divide both sides by 2. Y is equal to 4. So our solution is x is equal to 5. Y is equal to 4. At this point, we check the answer. Remember, solving simultaneous equations means finding values of x and y that satisfy both equations at the same time. So now we substitute x equals 5 and y equals 4 into both equations and check that the equalities are true. First equation, 3 times 5 plus 2 times 4 is equal to 23. 3 times 5 is 15. 2 times 4 is 8. 15 plus 8 is 23, so the first equation is satisfied. Second equation, 4 times 5 minus 2 times 4 is equal to 12. 4 times 5 is 20. 2 times 4 is 8. 20 minus 8 is 12. So the second equation is also satisfied. Since both equations are satisfied, this confirms that the solution is correct. Let's move to example 2. We have 3x minus 3y is equal to 9, and 2x plus y is equal to 12. The terms are already aligned, but this time we do not already have matching opposite coefficients, so we need to create them. Look at the y terms. In the first equation, we have minus 3y. In the second equation, we have plus y. To turn plus y into plus 3y, we multiply the whole second equation by 3. This is where students often make a mistake. We must multiply every term in the equation, not just the y term. So the second equation becomes 6x plus 3y is equal to 36. The first equation stays the same. We can now add the equations. 3x plus 6x gives 9x. minus 3y plus 3y cancel out. 9 plus 36 gives 45. So we get 9x is equal to 45. To solve for x, we divide both sides by 9. X is equal to 5. To find y, we can use one of the original equations. The second equation is convenient because the coefficient of y is just 1. So we use the second equation, 2x plus y is equal to 12. Substitute x is equal to 5. 2 times 5 plus y is equal to 12, which simplifies to 10 plus y is equal to 12. Move 10 to the right-hand side. Y is equal to 12 minus 10. So y is equal to 2. The solution is x is equal to 5, y is equal to 2. Let's check if the solution is correct by substituting x is equal to 5 and y is equal to 2 into both equations. From the first one, 3 times 5 minus 3 times 2 is equal to 9. 15 minus 6 is 9. So the first equation works. From the second one, 2 times 5 plus 2 is equal to 12. 10 plus 2 is 12. So the second equation works as well. That means the solution is correct. Let's look at the next example. In example 3, we have 4x plus 3y is equal to 9 and 5x plus 2y is equal to 13. The terms are aligned, but we do not have a variable with the same coefficient and opposite signs. This time, it is not enough to multiply only one equation. We need to multiply both equations. Here, we need to decide which variable we want to eliminate. We could choose either x or y. Usually, we choose the variable with the smaller coefficients so that we can work with smaller numbers. In this case, we will eliminate y. The coefficients of y are 3 and 2. So we want both y terms to become 6y but with opposite signs. We multiply the first equation by 2. Then we multiply the second equation by negative 3. Why negative 3? Because multiplying by 3 would give 6y, but we need the opposite sign. That gives 8x plus 6y is equal to 18. The second equation becomes negative 15x minus 6y is equal to negative 39. We can now add the equations. 8x minus 15x gives negative 7x. 6y minus 6y cancel out. 18 minus 39 gives negative 21. So, negative 7x is equal to negative 21. Divide both sides by negative 7. X is equal to 3. To find y, we substitute x is equal to 3 into one of the original equations. We use the first one, 4x plus 3y is equal to 9. Substitute x is equal to 3. 4 times 3 plus 3y is equal to 9. 4 times 3 is 12. So 12 plus 3y is equal to 9. Move 12 to the right-hand side. 3y is equal to 9 minus 12. So 3y is equal to negative 3. Divide both sides by 3, y is equal to negative 1. Our solution is x is equal to 3, y is equal to negative 1. Let's check. First equation, 4 times 3 plus 3 times negative 1 is equal to 9. 12 minus 3 is 9. Correct. Second equation, 5 times 3 plus 2 times negative 1 is equal to 13. 15 minus 2 is 13. Correct, so the solution is verified. Let's look at example 4. Here the equations are not aligned, so we need to rearrange them first to make sure the terms are in the same order in both equations. After rearranging, we get 3x minus 5y is equal to 10 and 4x plus 3y is equal to 52. Next, we choose a variable to eliminate. This time, we eliminate x. The coefficients of x are 3 and 4. So we multiply the first equation by 4 and the second equation by negative 3. The first equation becomes 12x minus 20y is equal to 40. The second equation becomes negative 12x minus 9y is equal to negative 156. We can now add the equations. 12x minus 12x cancel out. Negative 20y minus 9y gives negative 29y. 40 minus 156 gives negative 116. Divide both sides by negative 29, y is equal to 4. To find x, we can use the first equation written in its original form, because we already have 3x isolated on the left-hand side. We have 3x is equal to 10 plus 5y. Substitute y is equal to 4. 3x is equal to 10 plus 5 times 4. 5 times 4 is 20. So 3x is equal to 10 plus 20, which gives 3x is equal to 30. Divide both sides by 3. x is equal to 10. So the solution is x is equal to 10, y is equal to 4. Let's check if the solution is correct. From the first equation, 3 times 10 is equal to 10 plus 5 times 4. 3 times 10 is 30. 5 times 4 is 20. 10 plus 20 is also 30. So the first equation works. From the second equation, 3 times 4 is equal to 52 minus 4 times 10. 3 times 4 is 12. 4 times 10 is 40. 52 minus 40 is 12. So the second equation works as well. That means the solution is correct. Now let's look at another example. Here we have fractions. Before using elimination, we first want to remove the fractions. To do that, we multiply each equation by the lowest common multiple of the denominators in that specific equation. In the first equation, the denominators are 3 and 9. The lowest common multiple of 3 and 9 is 9. So we multiply the whole first equation by 9 to remove the denominators. Now let's look at the second equation. The denominators are 2 and 2, so the lowest common multiple is 2. So we multiply the whole second equation by 2 to remove the denominators. Multiplying the first equation by 9 gives 9 over 3x plus 9 over 9y is equal to 18. This simplifies to 3x plus y is equal to 18. Multiplying the second equation by 2 gives 2 over 2x minus 2 over 2y is equal to 6. This simplifies to x minus y is equal to 6. Now the equations are much easier to work with. We notice that the terms are aligned. The y terms already have opposite signs, so we can add the equations directly. 3x plus x gives 4x, and the y terms cancel out. 18 plus 6 gives 24, so we get 4x is equal to 24. Divide both sides by 4, x is equal to 6. To find y, we can use one of the simplified equations, as it is easier to work without fractions. Let's use 3x plus y is equal to 18. Substitute x is equal to 6. 3 times 6 plus y is equal to 18. This gives 18 plus y is equal to 18. Move 18 to the right-hand side. Y is equal to 18 minus 18. So, y is equal to 0. The solution is x is equal to 6, y is equal to 0. Let's check if the solution is correct. Instead of using the original equations with fractions, we can use the simplified equations, because they are equivalent and much easier to work with. From the first equation, 3 times 6 plus 0 is equal to 18. 18 plus 0 is 18. Correct. From the second equation, 6 minus 0 is equal to 6. Correct. So the solution is correct. Let's look at example 6. First, we align the terms by moving negative 3y to the left-hand side, where it becomes positive 3y. After aligning the terms, we have 2x plus y is equal to 4, and 6x plus 3y is equal to 12. We can eliminate either x or y by multiplying the first equation by negative 3. The first equation becomes negative 6x minus 3y is equal to negative 12. The second equation stays the same. We can now add the equations. Negative 6x plus 6x cancel out. Negative 3y plus 3y cancel out. Negative 12 plus 12 gives 0. So we get 0 is equal to 0. This statement is true. When this happens, it means the two equations actually represent the same line. So instead of having one point of intersection, we have infinitely many points in common. That means the simultaneous equations have infinitely many solutions. In other words, the two lines coincide. Let's look at the other special case. We have 2x minus y is equal to 1, and the second equation is 14x minus 7y is equal to negative 6. The terms are already aligned in both equations. To eliminate the variables, we multiply the first equation by negative 7. That gives negative 14x plus 7y is equal to negative 7. The second equation stays the same. Now we add the equations. Negative 14x plus 14x cancel out. 7y minus 7y cancel out. On the right-hand side, negative 7 plus negative 6 gives negative 13. So we get 0 is equal to negative 13. This is impossible. 0 can never be equal to negative 13. So these simultaneous equations have no solution. Geometrically, the solution of simultaneous equations is the point where the two lines intersect, meaning a point that belongs to both lines at the same time. In this case, there is no point of intersection, so the two lines are parallel and there is no solution. Now it's your turn. Try to solve these simultaneous equations using the elimination method. we have x plus y is equal to 11, and the second equation is 3x minus y is equal to 9. Pause the video, try it yourself, and then press play to check the solution. Let's solve it together. The terms are already aligned, and the y terms already have opposite signs, so we can add the equations directly. X plus 3x gives 4x. The y terms cancel out. 11 plus 9 gives 20. So, 4x is equal to 20. Divide both sides by 4, x is equal to 5. To find y, we substitute x is equal to 5 into one of the equations. We use the first one, x plus y is equal to 11. Substitute x is equal to 5. 5 plus y is equal to 11. Move 5 to the right-hand side. Y is equal to 11 minus 5. So, y is equal to 6. The solution is x is equal to 5, y is equal to 6. You can now verify the solution by substituting the values of x and y into both equations to double-check that the result is correct. That is the elimination method. If we find one value for x and one value for y, then the simultaneous equations have one solution. If we get 0 is equal to 0 or another identity that is always true, it means there are infinitely many solutions. In that case, the two lines have infinitely many points in common, so they coincide. If we get 0 equal to a number, which is a statement that is never true, then there is no solution. In that case, the two lines are parallel. I hope this video helped. Thank you for watching. See you in the next one.